This is a mix for the National 5 Wave Parameters key area, and this is the fourth one on speed, frequency and wavelength. What you need to know is you need to be able to calculate speed, frequency or wavelength using the relationship between the three of them, and you need to also be aware, as always, of the prefixes giga, mega and kilo, what they mean and how to make calculations with them. Let's remind ourselves about what frequency is: the number of waves every second, speed, the distance travelled in a second or just how fast something is moving, and wavelength, the distance between two identical points on the wave with the symbol lambda, often like that. And the relationship is, from the sheet, speed is frequency times wavelength. Speed, remember, is v, and frequency is f, lambda is the wavelength. Let's look at an example. A wave machine produces 6 waves in a second. What is the frequency? Frequency is 6 Hertz because there's 6 waves every second. Use the diagram to find the wavelengths. So here's our wave. We've got to work out the wavelength. So the wavelength is the distance of one wave. So one wave is there, to there, to there, to there, to there. So we have 1, 2, 3, 4 waves in 12 meters. So each wave is 12 divided by 4, which is 3 meters long. We're not asked about the amplitude, but the amplitude, remember, would be from the middle to the top. So that would be 1 meter. Now we have the frequency and the wavelength, we can work out the speed. V equals f times lambda. 3 times 6 is 18 meters per second. Let's look at another problem. What is the wavelength of the wave if the frequency is 2 Hertz and the speed is 4 meters per second? So wavelength is lambda, frequency is f, speed is v. Get used to writing where they are, because that will tell you what formula to pick when you're in an exam and there's a choice. Lambda is equal to v over f. Substitute in your numbers and you get 2 meters. Let's look at another one. What is the frequency? That's f of a wave that is traveling at 10 meters per second. So that's speed, which has a wavelength lambda of 2.5 meters per second. So we need f. So we cover that up, v over lambda. We substitute in the v, which is 10, and our wavelength, which is 2.5, and we get 4 Hertz. Now, a reminder about prefixes. If we're looking at radio waves or electromagnetic waves, they have much higher frequencies than water waves, so we need to know prefixes. So talk sport, for example, frequency of 1053 kilohertz. Wave 102, 102 megahertz. Your phone will be using signals that have gigahertz. So you need to know what they stand for. You need to know either the times 1,000 or the 10 to the 3. You use whatever you are most comfortable with. This table includes the giga. So, what's the frequency in hertz? Talk sport, 1089 kilohertz. So multiply by 1,000. Wave 102, 102 million. This won't be a question at National 5, but you will have to do this conversion when you're doing a calculation. So when we're doing v equals f lambda for radio waves, we need to remember their speed, 300 million meters per second, or 3 times 10 to the 8 meters per second. This is all electromagnetic waves. Your data sheet does have light, but it doesn't have radio waves or microwaves. So you have to know that they're the same. You have to put your unit if asked to. So what's the wavelength of wave 102? So that is lambda, that is f. Notice no speed in the question. That's because we're expected to know it's a radio wave and it travels at 3 times 10 to the 8 meters per second. Lambda equals v over f, 300 million divided by 102 million. Write it like that, or you could write it as 3 times 10 to the 8 divided by 102 times 10 to the 6. Both would be okay. You do what you prefer. That gives us 2.941176471 meters. You have 3 numbers for the 102, so the most you can put in your answer is 3. 2 is probably better, but 2.94 would be okay. If you're putting more than that, you will be deducted marks.